Hi everyone, and today I'm excited to share with you a new idea that I've been playing around with called a universal filter. So basically, these few days I've been quite inspired by the idea that consciousness might exist beyond the brain. And I recently went for a neuroscience and AI mini symposium, and over there, one of the speakers, Prof. Ho, he mentioned that during experiences like near-death experiences, the brain might actually show no activity at all. So the patient is basically clinically dead. But the patient has recollection of what happened in the operating theater, and in fact mentions that there's an even expanded form of awareness, right, when the brain is supposedly clinically dead. And the events that the patient mentioned correlates with what actually happens. So I was quite interested in this phenomena, and I went to read on texts about non-local consciousness, and this led me to a whole new world that there may be something non-physical out there. So this whole theory stems from my readings about this non-physical world, but it also applies to the physical world because actually the physical world, if you believe in those theories, is actually a manifestation of the non-physical. So essentially, we think of our reality right now. So it's a bit controversial, but there's a lot of evidence for this because the fact is like the body can heal itself using thoughts. Like the placebo effect works like this. Like you think that this drug is going to help you, and deep down the thoughts manipulate the biochemical processes to make it happen. So let's keep an open mind with all of this because of course this is still considered pseudoscience in a large part, although I think there's some gradual acceptance of all this. So just by looking at this text, what can we learn about how we learn? So that is the interesting part. I spent about 2 to 3 months reading all this, and here I've come up with an initial theory of how our intent works. And this is just a preliminary theory because I still have to do experimental validation and to make sure that, this makes sense. So just to share with you what the idea is. So in a nutshell, universal filter is about using our intent to filter out experiences, filter out our memory. In fact, we can also use intent to guide our actions. So it's very, very versatile. And this idea of intent is nothing very far from AI because large language models uses language, and language is a form of intent. So you can say, I want to go to the supermarket today. That is an intent. Then how you execute it, that's something that will get converted to the action space. Today, we will not be focusing too much on the action space. We will be focusing more on the state space, which is like, how do we get the information inside us? Like, how do we see? How do we hear? Like, how do we filter? And of course, there's also non-physical forms of filtering like telepathy and so on. So this is basically an idea that tries to merge both the physical and the non-physical worlds. But you don't need to believe in the non-physical for this to work because this works entirely in the physical world, this theory. Right? So let's begin. So the main thing out there, like out in the world, there's so many things happening. Like look, for example, at this street that you see, there's so many cars, there's so many people moving, lights flashing, and so on. Like, do we really, really want to learn from every single thing here? Or the more important question is it possible for us to learn from every single change here? All right. So, yeah, do you have any feedback? Like, do you think that we can learn from all the changes that we experience in the world?
I think it is extremely difficult to generalize from every single data point within our reality, and some level of hierarchy is required in order to have meaningful learning.
Definitely, yeah. So just take for any example, like someone trying to learn a new skill. Okay, you don't bombard that person with all the knowledge of, like, for example, you want to learn how to play a guitar. You don't teach people like immediately all the advanced string patterns and so on. You start maybe with like basic single string strumming, chords, and so on. So if you were to bombard all the information at once, you may not even have the right structure that is needed to learn. You may not even learn the basics on which you can do some scaffolding to learn even more advanced things. Likewise, for the information out there in the world, you might need to learn something first, and then you learn something more and something more. Or in this case, for a busy street, not everything that you see might be relevant to what you need to do, you see. And you may not want to learn every single thing because like how the signboard is flashing may not have any relevance to your life at all. And you may not want to put some effort to learn all this because it just simply doesn't matter to you. So you need to be very selective with what you choose to learn. And we also have some limited processing bandwidth. So it makes even more sense to choose what you want to learn from. So there's this whole thing that got the um, whole AI explosion recently started is the attention is all you need model. So attention is really like a filter. It chooses what you want to learn on, and you focus on that, and you learn relations in that narrow area. So let me give you an example. So look at this chunk of text here. There's welcome, hello, goodbye. Okay, I know it's hard to see when it's all jumbled up like that. So imagine if you have no filter at all. You take in all the information inside your eyes, all right? You take in everything. It looks like a bunch of red, blue, and green pixels. It's hard. It's hard to tell, like, what are you actually looking at? You see, the information in the real world is so messy. It looks like this. Okay, it is even more messier than this, but this is just an illustration. If you want to learn from everything here, what can you learn? Likely nothing. Like, I mean, you can learn that there's red, green, and blue pixels, but do they mean anything? It's hard to tell. Like, you can't really see all this and make an interesting relation or conclusion or learnings from this. But if you filter it, you say that, hey, ignore everything else. Just look at the red word only. And then you trace the red word out, you realize you can get hello. Okay, of course, hello here, it may not have any meaning to you if you don't know English. Then you can, use some code book to decipher it and so on. But the idea is compared to this signal over here, this information here, if you filter it, you will get a highly relevant to your use case here. In this case, maybe you want to figure out what's the code in red. Okay, maybe you know that, hey, this is a treasure hunt. You want to find something in red. So this may be the filtering is the first step to learning. Every single thing that you do in your life, you will need to filter in order to learn something from it. Like, there's so much information happening around you at all times. You can't possibly learn from everything at once. So you need to focus on what you want to learn, and then you derive some relations from there. So this is the case for anything. Like, for example, if you are trying to navigate, you're driving on a car, you're driving a car and then you want to navigate the road, you're going to a filter lane, going to the main lane. You know, there's a lot of things happening here. Like, there's a lot of cars over here. But, if you focus on all this, you may not focus on the more important thing, like whether there's a car here, because you need the filter. So a lot of things that we learn, and we actually don't learn anything that we haven't already, sensed most of the time. But most of the learning that happens is just learning how to filter, like learning the right places to focus our attention on. Like, if you learn the piano, it's not that you don't already know how to move your fingers, but you learn how to use your attention to focus your fingers to hit the right notes at the right time. So a lot of learning really can be narrowed down to the first step is having the right intent, and then using those intents to guide your filters. So essentially, this is the main topic for today. I just described like the entire process. So what can we learn from using intents to filter? How can we put this into a broader system to learn information about the world? So let's think about this. So by the way, this is entirely new. I would say this is quite groundbreaking because I don't really see many people thinking in this view. Like, I just recently thought of this. So feel free to chime in if you have anything else to add, because this is likely the direction I'm going to develop. In fact, even the agentic architectures I have, like Agent Joe, would also go into this direction because I believe this is the future for intelligence. So let's take a look. These are the sensory modalities we have right now. So we have we have taste, smell, we have hearing, the ears, we have touch, and we have sight. So most of the time, like deep learning models, or in fact, like even medical treatments, they treat each of this as distinct. Like you think that, hey, a taste is very, very different from what you see, right? You don't really mix together because like taste is mainly like, food. But sight also affects the taste sometimes. I mean, people have found some links like how the food is presented affects the taste. That's what they do in MasterChef. They present the food in a very nice way. So maybe that will increase the taste of it, perception of it. Yeah. So you might think that every single modality is different, right? Different pathways, and information don't interfere doesn't interfere with one another. But is it really? There's also this effect. I can't remember the name for it, where you can basically hear a sound, and then based on what you hear the sound and the lip pattern, you can either think it's a B or a P. Can't remember what effect, Magala effect or something. So basically, using the vision modality, you can affect the sound. So there's a lot of things that can actually happen, and it's quite naive to think that these modalities happen in isolation. All of this actually interfere with, in some sense, with one another. All these are information pathways in which you integrate the information in. So how can we model all this in a grand theory? So let us imagine that there's a source of information that is like the ground truth, and this ground truth is infinite. Okay, it basically models everything in the world. Okay, this is something very hard to imagine, but imagine that's a source of information that contains everything. Okay, I call this universal information. So how is this everything modeled, right? Universal information is so vague. But with this universal information, it leads the framework to know that, hey, there's a single source for everything. And from this source, we can derive our experience from it. So from this information, if you query it in different ways, like for example, if we use our skin cells to query like whether there's any pressure on it, you get the modality of touch. Of course, there's also stuff like heat and infrared and so on, because touch contains more than just pressure. But here I'm just using pressure to simplify it. So if we talk about filtering by saying, hey, I want to find out what chemical molecules entered my nose, okay, you might get a sense of smell, or like for taste buds, you get the sense of taste. When you filter to basically say that, hey, I want to find out what are the sound waves entering me. So you have this cochlea and you have the cilia in your ears, you get hearing, the sense of hearing, right? And of course, the most dominant sense of the human body, the sense of sight, you basically convert light waves, like EM waves, electromagnetic waves in the visible spectrum. They enter your rods and cones in your retina. And basically this gets converted to a pattern, and you eventually see something. So basically senses are a way to query the environment. So you use sensors, which are actually like material stuff, to form structures to query the world. And so the world itself, okay, is actually this universal information here. It contains all the information that happens in the world. But as an individual, it doesn't make sense to know everything in the world, because there's no need for you to know everything. You just need to know about what affects you, the individual. And that is where, evolution, biology has made us have this sense organs that can query the environment and find out information to feed back to us, right? To feedback what's around in the environment. And these senses have been evolved over time to give us information. So this senses, you can treat it as a filter. Okay, you do not need to purposely use an intent, say, hey, I want to know what smell it is. You don't have to. It's automatic. It comes into your awareness automatically. You don't have to say that, hey, I want to feel whether or not like this is ice water. You just dip your hand inside and then oh, this is cold. So this, you don't really need an intent to query this. The sense organ itself is the intent to query the world. So this is done automatically on your behalf by your body. Of course, there's this other component called other senses. I mean, people say, oh, sensory motor, you can feel where your body is. There's also other senses beyond the physical world. So this sounds a bit controversial. People have been known to enter an expanded state of consciousness or altered states of consciousness. There's this whole institute called the Monroe Institute, where people go into out-of-body experiences and they feel their awareness happening outside of the body. And from there, they are able to communicate like telepathically to other entities and so on. So these are the other senses where you actually, because you don't have an automatic querying that happens because of the physical nature of the sense organs, you have to actually have to use your mind to query. So that one, I'll cover it later, but I'm saying that this whole theory that I'm creating does not necessarily limit ourselves to just the physical body, because I believe consciousness is much more than that. Of course, if you don't believe that, it's fine. You can stick to the physical senses. The theory will work just fine. So there's one ground truth of information called universal information. And from there, you query information from this universal information to get like the five senses that we see right now. So, sometimes like what you get, that's not I was saying that, sometimes the pathways might interfere. Like maybe what you hear, and then you look at what the person's mouth is, the sense of sight and sense of hearing might interfere and give you different kind of interpretation. Okay, that happens later on. So after you do your querying, you might integrate this later. You might integrate them together to to sort of make sense of one another, because once you get information from various sources, it doesn't really mean that it must have independent processing pathways. The pathways might intersect, and then they might interfere with how you interpret the data. So this data here is uninterpreted, but after you query it, is the data that is interpreted. So this is very important, because this interpretation adds in bias to your data. But without this bias, you will have no meaning. All right. Data that exists as, like, maybe for this data exists as zeros and ones, or it could exist as a vector. I don't really restrict how you quantify universal information. Like, it doesn't really matter how you express it. The idea is that this information has no meaning if we don't interpret it. The sense organs are first layer filter to interpret this raw data, you call it, into something that means something personal for you. Like, you can hear things, you can touch things, you feel as though you are touching something, but actually it could just be data entering you, and you are interpreting that data in a meaningful way to convey some experience to yourself. So, I mean, the movie that illustrates this in some form is like the Matrix, where digital information, you get encoded in a simulation, and then you are in a simulation, and you can imagine like how it feels like to hear, to touch, to taste, to see. But all these are done in data. So in some sense, this is describing a simulation. Universal information could be the way that the simulation encodes the raw data. And then for each individual, you basically get data from this simulation to infer what's happening to you. Okay, so this is the first layer filter, the senses. Uh, let me just move on to the next part, then I'll open up to like some discussion. So after the senses filter, okay, we actually have the ability to control where to put our attention to. So basically, like in a cocktail party, you might have a lot of conversations happening, and then like maybe, someone calls your name. Immediately you might say, okay, I'll zoom in on the conversation that my name appeared in, because like I want to see I want to hear what's happening, what the person has to say about me. So this could be automatic, or you could intentionally say, hey, I want to look out for someone calling my name or someone calling another name. You can purposely, make that intent, and then you will find that you will focus more on things that fit your intent. Like, I'll give you an example. For example, if you want to hear the word apple, you tell yourself, I want to hear the word apple. And then you go to a room full of conversation, and then you just keep focusing on the word apple. You will be able to hear conversations that have the word apple, because like your mind already has this intent, and it works after your sense organs have, gotten the information from the world. You can actually use this intent to, to find out like what is in the sense organ, right? Of course, like the more interesting thing is like sight, because you can use your intent to not just interpret the data available. Okay, you can actually use your intent to control the sense organ. So I didn't really draw this in the framework, but like for example, if I want to focus on the lion on the right here, I can focus on the lion on the right. But what's more interesting is that once you focus your attention there, you can actually guide the information source, because your eyes can actually, move. The eye can focus on different areas. And like by saying that, hey, I want to focus on the lion on the right, what used to initially process the entire view, like maybe the left and the right lion, now I can just zoom in directly in the right on the right lion, and I can get even more data from it. I can get the features of the eyes, the nose, I can zoom in more, because we are able to guide through intent. We are able to guide the collection of data with the sense organs. So that's cool, because intent is very powerful. So although your sense organs already came up with the data, but you can use that to influence how the sense organs, acquire those data as well. So really, actually, if anything to do with AI or learning, intent is very important. Like it's underrated actually. Like we think that all information comes to us automatically. That's true to a partial extent. We actually can guide the collection of information in a way using our minds. All right, just by saying that, hey, I want to learn more about apples, maybe suddenly around you, everything around you, you will suddenly realize that there's a lot more things related to apples than you previously knew. All right. So I give you a case in point. All right. So recently one of my kitchen like glass panels cracked. So the crack appeared like this. And then there was a lot of lines and cracks and everything. Then I was like so mesmerized by this pattern. I was like, wow, this cracking pattern is like it's like fractals, like it's coming out. And then what I realized next is that I noticed something on my lift door at my apartment that I've never noticed before. So this is the lift door, right? So this is the lift. And then I realized that the patterns on the lift look exactly the same as the fractal kind of uh cracking pattern of the glass. And for the for the 2 to 3 years that I've been living there, I have never noticed this. But the moment I was like, wow, this pattern is so incredible, immediately after I noticed this pattern, I didn't even, intentionally focus on the door. I was just thinking, wow, this pattern is really nice. And I noticed it. Yeah, so actually if you have some intent to, to learn something, or if you have some intent to do something, you keep repeating that intent, you might actually cause changes in your attention to actually pick up more information about this from the world. So it's quite interesting, because we might think that our sense organs are fixed, right? Like what comes in is fixed. Actually, no. Your intent actually changes what comes in. So actually, maybe I should put in a feedback loop back here to the intent collection. Yep. So yeah, this is something that is quite revolutionary, because we are not just passive recipients of the information of the world. We can actually change how we receive it. Like, so this is just some examples. Okay, I'll just pause here because I've talked quite a bit. Do you all agree with this? You all have any thoughts or anything?
Sorry, I was trying to unmute. Yeah, a few questions. So in this framework, is the concept of filtering and querying interchangeable? Like basically each layer of like abstraction, you could call it. Is filtering and querying the same thing? How it controls the data flow and everything to every previous layer? Or like you were saying earlier, how your intent can actually control all the way to the beginning filter? So is the concept of like querying data and filtering data pretty interchangeable in this framework, or are they distinct actions?
Oh, good question. Actually, to me, querying and filtering are the same. When you query, you are filtering the data in such a way that you only receive back a subset of it, or modified subset of it. So, for example, this is your database. I mean, we use AI terms because I think most of the people here are AI people. So you actually want to you you perform a query maybe. So your query comes here. you query a database, you only get some answer here. Like the answer is actually a subset of information in the database. So essentially this query of the database, you can view it as, so the database here is universal information, all right? So you could view it as, you apply a filter here, and this filter maybe is like, it filters only the word apples. So essentially the way of applying a filter, so this filter is maybe filters only the word apples. And this query here could be apple. Like, so essentially in terms of the process of the filtering and the query reply system, there's not much difference, because you can treat a query as just a way to filter the database to get information that is relevant to you. Yeah, so I think there's no difference at all, in my opinion.
Gotcha. Okay. And all of this reading is any or this framework is any of it inspired perchance by predictive coding and anything neuroscience-y, or is this all purely consciousness and high level reading stuff like that? High or what do you call it? High level stuff, like nothing to do with like neuroscience or predictive coding.
Oh, there's things to do with neuroscience, because like neuroscience essentially like how you interpret your data. Um, I, I mean, neuroscience actually does quite a good job to describe how the brain function maps to your senses. Like I think we understand that pretty well. I think in some sense we know like how the filters are done internally, because these filters are fixed filters. Like for example, how you view your images. You go through the visual cortex, V1, V2, V4, and so on. All these are structures to help you filter. So you don't have to, intentionally query the world. You process data in such a way that, you can see objects, you can see like the individual details. And we also understand, like how our eyes move, how the muscles of our eyes can be controlled, like how saccades are formed. All this actually are well known. And I mean, I'm also inspired by this because I spent a lot of time reading on neuroscience. And we do have filters for each sense by that is defined physically. Like your ears have the cochlea, your cilia hairs on the cochlea help to vibrate at certain frequencies, hence helping you to hear those frequencies. So I believe all these filters are like structurally built for sense organs. But what neuroscience didn't really do too well is to use intent to guide the interpretation of the signals. Like neuroscience and biology are very focused on, like, the DNA encodes the structure. The structure is absolute. Like everything is based on structure. Okay, I think that's only one part of the equation, because if you look at the um mind body framework, like most people think that most like medicine people, they think that everything is the body, which is like the physical world. But actually mind, which is like the non-physical, mind affects, like if you read the text, mind actually affects the physical. So you might think that, it's a lot of materialist things that the body creates the mind, like, because of the neurons, I create consciousness in my brain. All right. And people have tried to find neural correlates of consciousness, which is like some Christmas tree activation in the brain. That actually it may just be, a correlation, a symptom of what's actually underlying the true nature of thought and thinking and mind. A mind might exist independent of the physical world, and just affects the body through his thoughts, through his intents. And so if you look at neuroscience texts, you will find a lot of information about this part, the body part, but you wouldn't find much information about the mind. Okay, how are emotions made? How are thoughts made? How is consciousness made? Neuroscience has tried to answer all these questions, but I don't find their answers satisfactory at all. Like, there's this worm called the planaria, all right? Planaria worm, Michael Levin, you can go and search his name. The planaria worm, he has dissected that worm into, I don't know how many bits, 60 over bits. He cut the worm into many, many small parts. And the beauty about the planaria is that once you cut into small parts, each of these worms here can actually grow back to the full size again. And what they have found out is that if you give this worm like a shock, and then it learns like avoid this shock by saying that, hey, maybe if if I give it certain chemicals that, actually is quite toxic to the worm actually, learns how to survive in that toxic chemical. And then you think that, hey, maybe the memory is stored only in a certain part of the worm, right? You might think that only certain parts of the worm, once regrown, will be immune to these toxins. But what Michael Levin has found is that all of the parts that regrow to the full worm, all are immune to the toxins. So what does this mean? Is there a memory area? Is there a brain to store these memories? Is there a specific cell component to store the memory? No, it turns out that memory is stored everywhere. All right. So Michael Levin has um, his his conclusion is that there must be something very, very micro that stores these memories. My conclusion is a bit different from his. I believe that memory is stored in the non-physical. Okay, that's why you cut the worm up into many bits. Each bit grows into a full worm again and has that memory. It's because memory is inherited not from the physical, but because this body is linked to some mind somewhere, some conscious mind somewhere. And this conscious mind, if you split the body into many parts, it might still be able to control each of these parts separately. And that's why you are able to, you know, based on that, get back your memory. Although you cut the worm in so many bits, all of them have the same memory. Maybe because maybe all come from the same mind. Another example, split brain patients. Um, you have two hemispheres for your brain, right? Your left hemisphere and the right hemisphere. Let's say this the left and the right. People have cut the corpus callosum inside, which is like the linkways between both brain hemispheres, and they realize that this person has two different kind of processing systems. Like the left brain doesn't talk to the right brain anymore. The person might stand up because someone flashed a cut on the right eye. I think the right eye goes to the logical brain, the left side. And then sorry, flash a cut at the other side. That's not the logical brain. Maybe the right eye and the left eye. I can't remember the experiment, but the idea is that the experimenters gave a cue to the person that did not involve logical processing. And so the person stood up. And then the experimenter asked, why do you stand up? And the person's like, oh, I don't really know why. But the person came up with an explanation anyway. Oh, I stood up because I was stretching my legs. Yeah. So the idea is that, once you cut here, so if let's say like where this thing is, like basically how do I put it? If let's say you have a memory system, okay, that is external to it, you might be able to, based on this, okay, this is my speculation. I actually think that the memory system, it's how do I put it? Yeah, if let's say the memory system is external to both hemispheres, like you might be able to control both hemispheres, and then once hemisphere gets the information, you know, maybe this information is not passed up to the external system because like you maybe need to consolidate the information first. So I'm still thinking about this. But let's say the hypothesis is correct that memory is external to the brain, then for this split brain patients, what could happen is that they know what's going on in one part because they have the senses for it, the logical processing for it. But maybe this is not stored in memory yet. Like so that's why the other side doesn't know. Yeah, I don't know. Or it could be it is actually a bad example, I realize. But yeah, the idea is that there's actually something else that is I guess the best way to prove it is that if we are able to learn basically to learn experiences, and then your left hemisphere and the right hemisphere both can query the same experiences. That would be the best way to show it, but it's a bit hard to show it because you need to shut down one hemisphere totally. Yeah. So let's ignore what I said about the split brain because I realize it doesn't really show that the memory mechanism is external. But we go back to the plane area. Yeah, I think that it's. I mean, there are many explanations for this. One explanation is that everything's stored in the chemical and the micro level. Yeah. So the thing is, we don't really know for sure. But I'm inspired by all these neuroscience readings and like all the readings about non-local consciousness. I think to some extent, non-local consciousness is true because like if not, how do we explain those near-death experiences, right? So yeah, this is just a belief I have. I'm trying to implement this belief out into an AI system. So yeah, I hope that clarifies where I got the ideas from.
Yeah, I'll just finish my point. If you go back to the first slide, the was it the first layer filtering? Yeah, right here. So my main point about the predictive coding is that this part of the framework is like very reminiscent of predictive coding, where basically you have each neuronal layer kind of predicting and minimizing the predictive loss, or the, what do you call it, the loss function of the previous layer of neurons, and they're all taking in pieces of data, and they're filtering that data per layer of neurons. Um, and basically trying to, each layer is by itself trying to minimize prediction loss and maximize kind of like its generative model of the world. But I think basically what you've done is that if you go to the second slide, what you're adding to this kind of like basic neuroscience framework of predictive coding is this intent. And this intent's ability to augment the already previously established pipeline of filtering and abstracting through layers of neurons and data, via the predictive coding and the generative modeling algorithms kind of the mind, and basically adding this intense ability to augment and to focus the attention aspects of, I guess you could say, prediction and of world modeling, which I think I haven't really read about predictive coding. Predictive coding has been kind of more abstract, kind of just focus on the general aspects of how neurons, or simplified models of neurons, kind of do their thing and try to coordinate with each other via the layers and coordinate data filtering. But I think your intent is actually a pretty missing part of like a lot of neuroscience papers that I'm familiar with. They don't really get into stuff like intent and what do you call it? It's the word I'm looking for. Um, Attention focusing.
Yeah, I think attention is also another word to say intent. Like you focus your attention on something that's like an intent to filter something. I do think that there's some consensus that attention plays a part in information processing. And the thing is, it's very hard to model or to picture human intent, you see. Like you can ask your subjects to say, hey, when you are intending to press a button, tell me. It's hard to measure that intent in your brain. Like, okay, maybe you can if you take EEG samples of a person's brain after performing that intent many, many times, and then you get a pattern, and then maybe you can detect intent in your brain. If not, actually, like general intent is very, very hard to tell. But I do think we are heading there. Like people are increasingly trying to map out where thoughts are in the brain. So that's something that like neuroscience is heading towards. And maybe in the end they might find out it's non-physical. Yeah, so so I'm actually looking forward to this because it will change the entire way we perceive reality if this is true. Right? We probably have no way to prove definitely that it's true, but there will be signs. There will be signs that the physical world is not enough to model everything. And anyway, just back to the predictive coding part, I still think the brain is doing predictive coding, no doubt about that. But the intent just can guide like what is predicted, because you predict a narrow section of what your actual stimuli is. So the brain is still a predictive machine. In fact, that's how we train our brains to perform stuff like play the piano. We try to predict where our fingers should be, and eventually, if this is done right, this will be out of conscious awareness. Like, so I mean, this is a good segue into like something that I will talk about in part two, not today, but like in terms of like the mind, which is like the conscious part, and the body, which I mainly call it the unconscious or the subconscious. Like I do think that there's two different systems of actions here, and if you train your body, your mind well enough, you might be able to do stuff that doesn't require consciousness, like muscle memory. You can play the piano without even thinking very hard about it. You might be able to ride a bike. You might be able to walk because your body has already done the necessary things to automate it. Yeah, so you can treat like your intent as a way to shape how your body becomes. Like for athletes, they can predict the ball, like tennis players, they can predict the ball so fast, even without conscious awareness. Like the ball flies in at like, I don't know how many km per hour, but at such a fast rate that you can't possibly use your thoughts to say, hey, the ball is going right, I need to receive it. That your body needs to react first. And through years of training, they have managed to train those muscle memories inside their body, their brain. Right? I would say it's both the body and the brain, because increasingly I've come to realize the brain is not everything. Actually, the cells in your body actually can learn as well. It's not just the brain. Yeah. So this is something that I think is missing right now in terms of awareness that like there's something more than just the body, because everything right now the focus is just on the body. Yeah. So anyway, this is just some segue into saying that there are different action spaces, some action spaces at the top, some action spaces at the bottom. So I'll cover this another time. All right. So okay, let's move on. So can we use this knowledge to do multimodal processing? Right now, we think that every single pipeline is like separate. Like vision, you have vision models, sound, you have sound models. Can we represent everything as a single model, maybe? What if we can find a way to encode data using something like universal information, where it represents all five senses and even more, if you want to include more senses? Then you don't need any like separate pipelines for each modality. You can store this information in universal information, and just simply applying different filters for your different senses, you get the information you need for each sense. So in some sense, this is something like a multimodal LLM. You take in like image, audio, text, and then you output image, audio, text. Okay, I mean, we don't really have this to this extent yet. Like in some sense, the image and audio pipeline are kind of separate. But theoretically, if you can encode all information into a common substrate, it should not be impossible for this to happen. Like you can have multimodal outputs, truly multimodal outputs, and truly multimodal inputs. And all these are done if you can encode the information in the right space. So how do we do this? Yeah. So let's okay. So before we go into how we do this, this is like how we can learn. Each individual can learn different experiences by just querying the same universal information. So over here, this universal information is a global one that you can treat it like a sort of like accumulation of everyone's experience. And then if you, let's say individual one like myself, my sense organs query the world, I can get different information from it. Okay, other is like maybe other senses, like so you can get different information from querying this. And another individual, maybe you can query it and you get different information. So to you and me, it's like we are both separate, right? We are both different individuals. But actually, we can come from the same system, right? Because essentially, the way this works is that, you are just querying differently because maybe your filters are applied at different space in the space-time universe. So individual one, okay, let's say this is the world. Individual one might be here. So you get sense data from this part. Individual two might be here. But essentially, all these are in the same world, and all this world is stored in the universal information. So this is the idea that, if we are living in a simulation, each of us are avatars, and we can receive information from the world, and then we interpret this information by ourselves. This is exactly where I'm heading towards, right? You can model the reality that we are living in right now as a sort of simulation where you receive information by just querying the game system. All right. In this case, universal information might be the game system. You query it, you get your own individual sense inputs, and then you interpret this in your own way. You can say, oh, I'm feeling pain now. Oh, I'm seeing a lion now. Yeah. And the interesting thing about this, as I mentioned earlier, is that you can only get meaning after you interpret your data. So like if you don't interpret your data, actually, let's say we look at the vision part, if you just look at this, it just looks like a bunch of numbers. But you need to interpret it in some way that makes sense to you. Right? Then you can see, oh, it's lions. Right. So this is something that I would like to emphasize. The meaning only arises after you put some bias on the raw data. So like sense organs put bias in some way, and then after that you interpret those bias in your own way. Okay, so this universal information is like there's there's no real meaning to this until you apply your own bias, which is like maybe your own code books, your own way of viewing this data. Like different people have different ways of viewing it. So even if I give this vector to you, if your vision module is trained in a different way from mine, like maybe you have different experiences, this vector might mean different things to you as compared to me. So both individuals might receive the same data, but they might interpret it differently. So it all depends on how you filter it, like how you filter your raw data. So this is something quite interesting because in the LM space right now, there's only one individual, there's only one LM, and the LM has the same token representations, have the same way of processing those tokens. But that's not true in a multi-agent system. In the multi-agent system, everyone has their different experiences. Everyone has different ways of interpreting those data. And in order for like a truly fruitful simulation to happen, you cannot have everyone interpret things the same way, right? If everyone interprets things the same way, what you learn will be very limited because everyone might do the same actions and so on. So essentially, the idea that everyone interprets things using their own filters and they get different meanings according to their own filters, I think that is the way ahead. All right, that's the way ahead. We need individuals that are not the same, okay? Because same individuals, you don't get much exploration.
Hello, can I add some comment here?
Yes.
I do agree with your opinion, but I do think different LLMs, especially those are trained by different labs, they do represent information in different ways because their embeddings are learned end to end, and if you look at their architecture, they are not exactly the same, right? Like different components, different hyperparameters, different way of encoding, like different implementation of attention mechanisms, different way of doing embeddings. All these differences will result in my opinion and in my own use experience, um, they will have they will in given the exact same query, they will because of their all these differences in the implementation of the architecture, the inductive bias will act differently, and because of that, the way they do search, they are focusing on likely different space in the latent space. So if you give a very complex problem to say O3 and Gemini 2.5 Pro, you can observe their traits. Actually, they have different focuses, and actually, that's actually one good use of a multi-agent system, right? Because you have both are very good reasoning models, but they cover different because the way they approach the problem, they do the reasoning is different. Actually, they can complement each other, and exactly it's because of that I'm saying that even though they are all transformers based architecture, but they do have different focus, and using your language, they are filtering different parts of the information. Yeah, that's my take on this.
Oh, definitely. You can treat different LLMs as like different individuals in the same role, because they actually have different experiences because they are trained with different pre-training data sets, different training schemes and so on. So they have different experiences already, and each of them can interpret the world in a different way because you give them the same sentence, maybe they give you different responses. Give them same instruction, they give you different responses depending on the training data. So in some sense, yes, they can be individuals, and that's a good point you made. Like complementary, if you make all of them cooperate with one another, like maybe take majority vote or like pass through one LM, then pass the response to another LM. Like for example, to do code correction, you find that maybe you combine all the LMs together, you get the best response Because yes, each individual has different experiences. Each individual has the ability to interpret the data in different ways, like they can find different errors. And exactly this is what I'm talking about. We need to have individuation because then you can explore more of the search space. So essentially, this learning of meaning is done through experience. It's done through iterating with the world and making sense of what this vector means to you, like based on your previous data you have. This is exactly what this learning process is, except that LLMs don't learn. Okay, LLMs learn only at the beginning, you see. After that, they stop learning because you freeze the weights and you use it. For a true learning system to happen, the LLM needs to be in the world itself. It needs to chart its own experiences. Like, for example, if it's a coding agent, it needs to be able to learn from the new code that he has done, which code is successful, which code is not, put in some database, retrain the model again to continually learn from this and, continually make sense of a changing environment. Then yes, then this can be viewed as an individual in the simulation. Right now, what you do for this language models is that you train it with forced experiences because like you force the pre-training data on them and they don't get a chance to correct themselves. Like you see coding agents right now, they might use like PyTorch that is an older version or TensorFlow that's an older version of what is actually needed right now. This because they don't update themselves. You see, like they get stuck. You might think that they are learning. Essentially, someone is force feeding them the new information. That's why like the latest models trained with the latest data, they might perform better because this information has been curated, selected by someone, by a human to let them be more proficient at some benchmarks. So I wouldn't say that they are learning entities. They are more like static programs right now. Although using this static program framework of updating the pre-training and doing again the whole cycle, if this part can be done automatically, I would say that yes, it will look like a learning entity because then it will be able to choose its experiences and learn from it. Yeah, I did that make sense? Sorry, did that make sense? Like, yeah, okay, good. You said yes. All right. So interpretation and filtering is really, really very important. And just from a raw stream of data, you interpret with your filters and you get your experience. You get your meaning attributed to your raw data that you receive. So essentially learning, I mean, if you view it this way, learning is quite bland, right? Like it's just taking some data and making sense of it. That's learning. And not just any data, but data that is relevant to you. Like if you look here in this case, you don't take individuals to data and learn, you can't. Your filters don't allow for that. Okay, although maybe if this individual too has learned something useful for you, you might want to learn from that person. So how do we do that? Later, if you have time, I will talk about the mechanisms, but let's move on. So exactly, this is what we are talking about just now, like different LLMs have different ways of processing stuff. So these are two philosophical questions that, we can think about. All right. How can you be sure that like one observer and another observer, interpret the same data in the same way? So let's say both of us are in the same position. We see a red apple. How can I be sure that, that redness that I'm seeing is the same as yours? I mean, yes, it's the same apple, you can be sure. But let's say if we are seeing two different apples and then I'm saying, hey, this apple is red. And then you are saying that, hey, this apple is red also. But what if you are like colorblind? You interpret a green apple as a red. How can we be sure that your red is my red? Right? Let's think about that. And also, like, if let's say one observer is a bat, let's say this is human and this is a bat. Like, how would we know how a bat sees? How would we know how a bat echolocates? The thing is, how can we interpret our experience to the other person's experience? It depends on how similar the experience is, right? Like, if let's say you are seeing an experience with let's say, for example, you see the whole world as black and white only, and I see with color. I mean, technically, we can still relate our experience to one another because we still see the same stuff, except, you may not have as much resolution because you get only black and white, but we still know, oh, there's a person moving, there's a fruit rolling down the road, but you may not know that fruit is red color. Yeah, but the experiences can be quite relatable, like, because it's quite similar. But if we talk about like a human and a bat, like how does it feel like to fly? How does it feel like to echolocate? You may not be able to, no, may not have a direct mapping. And so this is what I would like to talk about learning. Learning only can happen at the age of your knowledge set. All right. You can only learn stuff that can fit into your framework that you already know and you can add on to it. So if it's something like black and white to red, then maybe you can add on to it because like, okay, I already know that the world works like that. Okay, red might be something I cannot see, but I can map it to this black color. This black might be your red. I can make a mapping there. I can form a link in your existing set of information. So this is very, very nice because I can learn from your experience by just, mapping it to what I already know. So my set of filters, my set of knowledge is very, very important for my learning. And you can share with me stuff and I'll learn from that by expanding my set of knowledge. Okay, I have a set of slides later for that, but let me just draw. This is my knowledge boundary. Like this is my knowledge boundary. Okay, I can add on to my knowledge boundary, okay, by just, from this concept here, I can add on to, I can link, okay, if it's something that, can fit into my existing world model. But if it's something that is very far-fetched over here, there's nothing, like for example, this is echolocation and these are like walking, there's no link, or like this is flying and this walking, I can't really feel it, like then I won't be able to find out that knowledge, unless I can replicate, make myself like a bat fly, try to experience it. Then maybe you can link it here. Yeah, but this filters itself, let me just highlight this point. Okay, filters for learning make efficient learning, okay, at the expense of losing information about those that are not within the filters or knowledge base. So let's go back to LLMs. I think LLMs everyone understands. For LLMs, you can have LLMs learning about some knowledge, like for example, you learn how to code in maybe Python, right, by using lots of Python examples. Then maybe because of your focus with Python, you may not be very good at using C or C++ or like another language, Perl maybe. So the more you learn about Python, the less capable you are at other languages because like maybe you are focusing a lot of your knowledge base will be on how to use Python. And yeah, this means that your information representation by your filters will be more and more catered towards Python, So talking about LM terms, more of your tokens may be used to represent Python code than any other code. So this is basically something that we need to pay. This is a price we need to pay. By being more efficient at something, you necessarily must be less efficient at something else. This is definite, all right? If you want to be good at, like, let's say you have a limited bandwidth to learn things, you want to be good at English, necessarily means you need to be poorer at another language. Okay, unless your brain capacity is bigger, all right? So this is the idea of filters. You use filters to learn, and you interpret things in a unique manner that has meaning to you. But what this means is that you will lose out on information that is not within your filter base or your knowledge base. And compared to someone totally brand new, you may not be able to learn this very well. So it's like if someone is brand new, doesn't know how to walk, only can fly, maybe that someone can link the can be able to understand how it feels like to fly like a bat because that person may be born in the world with jetpacks. You can fly already. Yeah. That kind of thing. So filters are necessary for learning, and filters can also limit learning new stuff after that. So this is food for thought. Maybe I'll just open up again. Like, I'm interested to hear your thoughts about this. Like, what do you all think about this theory of using filters for learning, and like how these filters affect the knowledge base and so on? Like, I want to hear your thoughts on this. Anyone?
I have a comment, related comment, but not exactly on the filter part. It's on your, I think earlier you shared your view on um something to do with muscle memory, right?
Yeah, correct. So I'm saying that in the mind body framework, the mind is more conscious, like it does more intent based stuff, and the body is more like unconscious stuff, which actually can do stuff like play piano, return a serve. Yeah, so these are like muscle memory. Yeah, so
What are the evidence suggests? I think you just now you shared a claim that for the second unconscious action, uh like how, yeah, I think your claim is the body is handling it, right, instead of the brain.
I mean I treat body and brain as the same, like body as in
No, no,
physical.
no. Physically speaking, you can only choose one. If you say it's brain, means the signal travel back to brain and travel from your uh, brain to your body to have action, or it just happen locally within the body parts itself. So you can only choose one.
Why?
Because it's physical. So if you claim it's a body's doing, then sorry, if your claim is it's solely body's doing without any involvement of the brain, then is that your claim?
No, 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 no. By body I also mean brain. Like I mean the physical world.
No, no, no. I'm talking about for the human physically for the unconscious action. My question, my clarification is: do you think brain is involved for those unconscious?
Oh, of course, of course. Like breathing is an unconscious effort, right? And the brain is
What
also,
about the examples you gave here, playing piano and returning a serve?
yeah, your brain is needed as well.
So yeah, so then I'm not sure. In that case, I'm not sure why there's such a need for a distinction of saying it's brain or it's body. If the brain is involved, it's brain,
Okay,
right?
so this is where materialist views only encompass this part here, where everything is physical. What I'm increasingly aware of is that there's this non-physical component that can affect even the brain and the body, because like both are physical manifestations of the mind. What happens is that, let's say you want to play the piano, so you will lead this thought will lead to a series of activations in the brain that will control your motor neurons in your fingers. And as you play initially, it's a bit slow because you need to map those thoughts back into the motor actions. After a while, as you learn, your brain gets very proficient, your brain maps get updated to make playing the piece become effortless, because like whenever you hear like a certain series of notes, immediately by correlation, by pattern recognition, by prediction, you know what to play next. And this part here is done by like repetition. Your predictive coding model in the brain becomes so good that even without much thought at all from you, you just say, I want to play this piece. You don't even need to tell, okay, first finger move here, second finger move here. No, I play the piano. Like for pieces that I already know, my fingers move on their own essentially. Like I don't even feel like I'm controlling my fingers. If you understand what I mean. Like so this like walking. Do you feel like you're controlling your thighs, your legs, and everything when you walk? Not really, right? You're just thinking, I want to go from point A to point B, and your body takes you there. So this is what I mean by like unconscious efforts, which means that you don't need to intentionally will every single muscle body part to move. It just does it because your brain is so good at predictive coding. It already predicts what you should do next in order to reach a certain destination.
But in my view, that can be fully explained through system one and two thinking framework. Why do you feel the need to introduce like materialistic or non-materialistic? I
Oh,
don't.
system one and system two might exist in the non-physical realm as well. You'll be surprised. Like intuition, do you think it really comes from the brain? This food for thought, all right? I mean, there's no hard truth here, but because there's no way to prove it, there's no way to prove something beyond the physical realm. But I'm increasingly coming to the awareness that intuition could be something that is beyond like the five senses. Like you might be able to get some intuition elsewhere. Okay.
Okay, the following is just my own conjecture or understanding. I'm not, disclaimer, I'm not very well versed in neuroscience, but I feel like this can still be fully explained without introducing non-physical phenomenon, because season 2 is basically you do not need to you already learn a skill. That's why for what things like working or the skill you are very familiar and have your own mastery over it. You just, because you already the skill is already ingrained in your so-called muscle memory, right? You just do it like playing piano. You do not need to think of each individual atomic action. And if you do not need to think through it, you simply do it very fast because you are not learning it, you already learn it. So the circuitry in your brain has like formed this kind of connection for you to perform the skill. That's why it's very fast. As opposed to if you first learn a new skill set, you are trying to learn it, and the kind of some kind of circuit in your brain, like it has not learned the skill yet, so you need to form the the route or the signal traveling or whatever. That's why it's slow. So I don't see the need of introducing things like other than physical phenomenon to explain this. Yeah.
I mean, for this particular example, maybe you can just use everything to do with the brain controlling processes. Yes, I mean you can view it that way. But actually, if you think about it, I mean that might just be the after effect of the mind exerting influence on the brain. But of course, you don't need to view the mind part. What I'm saying that is that for learning, the kind of filters that you have learned at this level, so the filters that you learn from the sense organs, okay, it might actually be affected by what you have done. Like if you train the piano a lot, your sense organs might be more receptive to touch in a certain way. So these filters are actually linked to like the body or the brain. I mean, and as you practice more, you get more proficient at this. Yeah. So this is the in fact actually at the mind level, there's also filters for intent. Like for example, language. When you learn language and stuff like that, you learn a particular way of doing things. Like for example, walk, move, uh, uh, push, that kind of things that you learn in language can be used to guide like your brain and body as to where to go next, what to learn. So there are filters existing at all levels. Yeah. So
Sure.
yeah. So this is what I was talking about in the previous few slides. Like you have filters for your sense organs and you have filters for your intent. The sense organs filters can also be affected by your intent. Yeah, so I have a distinction here because I don't believe that the brain creates the intent. Rather, the intent shapes the brain. Yeah, you get what I'm saying?
So intent is this beyond physical?
It is beyond physical. That's right.
So then I think you need to also accept um if you accept this explanation, you also need to accept that things other than humans also have this kind of intent and so-called
Yes,
or
yes.
whatever. Okay.
Plants, animals. Yes, I
I think, yeah, because I think that's a very difficult thing for a lot of people to accept. So I'm just trying to point it out. Yeah.
correct. So
Mm.
actually, if you want to remain the materialist realm, it's perfectly fine. You can just treat intent as generated by the brain, and this whole theory would still work. Yeah, so I'm perfectly okay to view everything in the materialist realm just for the sake of
So what's your motive of again introducing non-materialistic phenomena to view? Because those things are unfalsifiable. So why would you?
there are things that I gain insight from because of stuff like telepathic studies, like how to send intent from one person to another without anything in the physical realm. I've been quite inspired by all this, and I've come to see that the way we operate in the physical realm might be all related to how we operate the non-physical realm. So I'll treat it as a cause and effect. The cause is the non-physical and the effect is the physical. So all along we've been trying to study the physical. But if you open your mind a little and just accept that, okay, there might be something that could affect the physical world, like some intent that came from like the non-physical, and that opens the doors for a lot of things
All
to
right. Okay.
interpret the world. So in some sense, it's an expansion of a worldview in which I hope to derive a more complete theory for learning. And
Okay.
yeah,
I think we can discuss more offline if you want.
yeah, no problem. I mean, I know this is controversial. I did not believe in this 2 months ago, but I've been reading up, and the evidence has been mounting. There's a lot of evidence for this, in peer-reviewed journals as well, like near-death experiences that prove that, okay, not say prove, but like a lot of anecdotes that people have said that the mind exists outside of the body because they are able to observe conversations outside of the operating theater and so on. That actually correlates to what happens, and this is the kind of thing that like it's very hard to fake. Like even if you are skeptical about it, it's very hard to fake all this. And if let's say we accept this, we expand our worldview, we can model a lot more things that happen in the world right now. So that's exactly the intent for today. Like I just want to introduce a new kind of worldview, a new kind of concept of filters. Yep. Yeah, Derek, you want to say something?
I do have a inquiry about this non-physical aspect. So the idea of, say, consciousness and intent, all these very high level non-physical things, are these non-physical, I guess, call them concepts or objects? Um, are they emergent behaviors? Are they emergent of the brain and body, of its mechanisms, of its neurology, of its, memory storage and engineering to a degree, or I should say its design almost? Are these non-physical concepts emergent from the physical world? And then the emergent non-physical um, behaviors, consciousness, and concepts, do they then have an influence on the physical body? So kind of tying back to the feedback loop, right, between mind and body, mind and brain slash body, where one causes the other, the consciousness, and then the high level consciousness and intents and abstractions, ideas, have their influence on the physical body, influence your health, influence your reactions, influence your memories and how you interpret them, and therefore how your memories get stored over time, things like that. Is that kind of where your framework's at, or is that more of like an interpretation of the more general framework?
Yeah, I'm interested in how to model reality in some sense. So I believe the mind and body influences one another. Like for example, if you want to do something, like your mind says, I want to go to location A, your body responds. And then if let's say your body feels tired, it will feedback to your mind saying that, hey, my muscle is, I mean, I don't have much energy. And then you might think that, oh, I'm feeling tired now. So you start to gain the experiences. So I would say that the memory of like who you are, your memory, personality is stored in the non-physical because like day to day our cells change and stuff like that. If you store the memory in the cells, it's very hard to explain this. Like how do groups of cells that die off and form new cells, how do they learn personality? How do they learn who you are? It's very hard to say that. Um, but I also believe in there's some memory that's stored here also, and this memory is like the muscle memory stuff. That is makes the intent easier to execute. So you can treat the physical body as something that can be trained to do your intent more efficiently. The more you do it, the more your brain structure and your body structure will modify itself to suit your intent. Like for example, you want to be a bodybuilder, your mind will say that I need to train hard, I need to build muscles, and then your body will react according to that, and then you start to develop the muscles and so on. Same thing if you want to like play chess, you can say I want to be a very good like chess player, and then after a while your systems will learn like, okay, actually the chess player one is more of here. All right, the memory here will be better to play chess. Okay, let's talk about something more physical. Like if you want to learn typing maybe or learn piano, then your body structure will your brain will give more brain territory to mapping the fingers, and that will be directly correlated to your performance at that task. And that's why I say all this affects one another. It's not just me that says it. Like if you just search mind body stuff, like there's a lot of people that say it, and I've been kind of ignoring this for a while, but now I realize it's actually very important, because if we accept that there's an intent that is driving our learning, we can model this intent in our learning framework and make it even more powerful than just, we are passive recipient of knowledge in the world and we don't choose our experiences. No. I mean, to choose our experiences in the RL framework, reinforcement learning framework, to choose experiences equals to choose actions. But this is very myopic, because the thing is, actions derive from intentions. If we don't model the intention, we are just modeling the root layer of the choosing process. But if we can model the intention, say like, for example, I want to learn piano, then your actions might be, oh, move left finger, move right finger. That is the micro level actions. But if you look at the broad level intention, you can actually model much more, because you can then learn more things, like all the hierarchical action space. Is it really hierarchical, or is it more like a hierarchy of intentions? Right. So more on this next time, okay? Because I haven't done the slides for this. But if we expand our worldview to beyond just actions and just think of intention, in the past, I would say intention is a goal in my goal directed framework. Goal is an intention. Having a goal is an intention. So there's something very powerful about having a goal, having an intention, and we need to model this in the learning framework. There's no way you can learn if you don't have an intention to learn. Yeah. So I think this is quite important, and it's two way. So as I said, the body can influence your intention as well, because if your body tells you, hey, my fingers don't move too well, then maybe your intention can say, maybe I'll just learn something else. That two-way street is necessary, because if your body is not able to do it, you know, you can't exactly force it to. Like if you can't walk, I mean, maybe you can will yourself to walk, but that's very difficult. Like, so I'm saying this is a two-way communication. It affects your experiences, it affects what you want to do next, and so on. Yeah.
Yeah, I think the best way to make this easy for people to swallow and kind of like wrap their head around so it doesn't sound too esoteric might be the software hardware analogy, right? Because obviously the brain and body are the hardware, right? They're physical. You can physically interact with them and observe their behavior. And then obviously your brain and body work together in conjunction to generate the software of the mind, literally the mind. Generate your consciousness emerges from your body interacting over time and building yourself up, and you develop a personality based on your memories and your experiences, right? So that's very um, analogous to the software almost, right? Your hardware is always going to have a preset architecture to it, right? Your body and its epigenetics work in a certain way, but that the way it interacts can generate different types of softwares, different types of memories that are non-local, right? It could be anything, right? That flexibility is like the software aspect almost.
Definitely. So as I was saying earlier to Zeri, it is perfectly possible to model this entire framework in a physicalist view. Like we can just say intent is a process of the brain that is emergent. And you can say it's the software of the brain, and the hardware will be the execution, which is the action space or the muscles. But perfectly fine to model like that. I mean, you can make the theory into this way. It wouldn't really change the theory. You will still have the two layers of intent that I've shown here. You still have the intent from your physical space and the intent from the software space. All right, so it's perfectly fine to view it like that. What I'm saying is that I believe that this software space exists independently of the body. But of course, regardless of how my beliefs are shaped, it doesn't change the fact that you can still have intent that exists as a body process, and it won't change the framework. Yeah, so I think you're right. We can frame it as that, but I prefer to be a bit more blunt about where I got my inspiration from. Yeah, my inspiration is from non-local consciousness. So it might be hard to digest, but no, you don't have to believe in it to use the theory. Yeah, you can just take the takeaways from it. Okay, so let's talk about do I have time to talk about this? Maybe I talk about this last part on time. I think we are reaching the end of today. I don't want to overshoot. I think what I'll do is I'll just briefly explain what I'll be covering next. We cover this another time next week. So what will happen next is that in order to model our current reality, we need to model the flow of time, because I know it will shock a lot of people, but the space-time rule set that we live in right now is actually not fundamental to reality. This is just an imagined simulation. Okay, there's a lot of people talking about this. A lot of physicists have come to this conclusion also because of quantum theory. A lot of things in quantum theory where the particle spins can get entangled and go across distances. You observe one, you change the other. That doesn't make sense in a space-time rule set at all. Another thing is double slit experiment. If you observe the electrons flowing through the slit versus you don't observe, you get different results. Also doesn't make sense in a space-time rule set. So it makes a lot of sense if we are in a simulation and what we observe gets rendered from a probabilistic uh, outcome space. So it makes sense in this way. I've been spending some time taking a look at the quantum theories part as well. And previously, I've been mentioning that the brain doesn't do probabilities. Only half right. I mean, the brain, as in consciously, you don't do probabilities, but the reality simulator you are in does probabilities. So, so I think probabilistic modeling is still needed. So more on this. This is a bit worldview changing. But if we do accept that we are living in a simulation, we can model the um, data that we receive as a stream of time, and we can even query what happens at previous timings. And like what happens in earlier time, you might call it memory. What happens in the future, you might call it precognition. All exist in the same spectrum. Just that this precognition is not easy to do because not everyone has access to it. But the querying your memory, the one everyone has access to their memories. Some people with access to the precognition part might be able to query the past even more accurately than what we store in memory because they have access to another database. Of course, these are all like anecdotal. It's very hard to prove this with science. But the theory, as I said, doesn't need this to work doesn't need you to believe in this in order for this to work. You can just say that, yes, I can have time as a separate filter. I can filter by time, and then I can filter my data stream with respect to time. And by filtering with respect to time, you can get stuff like audio streams, you can get stuff like videos. So a video is nothing more than a series of images stitched together in time. So this is something that is important in AI systems. We need to model time in some way. And now we go through this more next week. Um, how to model abstraction spaces, how to learn the filters, how to learn the new filters, and how to learn the latent space, very similar to next token prediction, and how to send stuff to one another, either through direct communication with a codebook or through some telepathic means where you have some way of converting different kinds of knowledge to one another. All right, so we'll cover all this next time. And just to end off on this slide, so I'd like to thank Dr. Seng Beng Ho, who has introduced me to one of the key facts that like learning and memory might exist beyond the brain. Because if you look at like near-death experiences, the brain is totally shut off, but the person still has recollection of what's going on. That's that's life-changing to me because I have always believed the world is just physical. I I mean after after I went to read more of this, I realized that there's so much more than what we know that exists. Yeah, this is something quite life-changing that led me to this theory and this Dr. Sebeho. I also went to read Thomas Campbell. My big theory of everything, and that also describes how the physical world can be derived from the non-physical. So I encourage you to read this book if you're interested. This was life-changing for me as well. And yeah, of course, a lot of Cambridge AI is my PhD lab group. I've been talking to them about this as well. And also I've been reading a lot of text and YouTube videos on this consciousness as well. So if you're interested, these are the people that I've been reading from. So you can also read if you're interested. So yeah, I will just end here for today because I think the next few parts about talking about time, talking about how to learn the filters will take a while, and I want to, discuss them more in depth. Okay, just to emphasize, this is just a theory I have right now, a preliminary idea based on months of reading this text. I haven't really tested them yet, but I think that they will work because the intent-based modeling is very similar to the paper I have. The paper that I have was the goal-directed memory-based learning. I did it for my agentic framework, Agent Joe, and also I have a paper on this that talks about this method. Um, the first time I did it was the learning fast and slow paper. You can check it out, where you have a way to learn goal-directed actions. So I realized that all these papers that I did in the past are just a subset of intent-based learning. Intent-based learning that and a memory that exists beyond the brain. Actually, all this can model all this, but this is just a subset of the true learning mechanism that happens. So yeah, quite excited to actually implement all this out. And yeah, before I end today, maybe a short 1-2 minute, you all have anything else you want to discuss before we conclude for today?
So your today's talk is titled Universal Filter.
Yes.
So, but I think from what you have covered, it's more like each individual has their own filter. So what is the universal filter?
Oh, it's a universal way to filter the data, and that filters can be shaped by individuals. So essentially, it's an individual filter, but the way you filter it is essentially limitless. You can filter it all kinds of ways that are just subject to your knowledge about the world. The more knowledge you have, the more you can filter. Like if you know about stuff like red cars, green, let me show you the slide. If you know about stuff like, green, loud, or this, you can filter them in that way. You can say that I want to focus only on those things. But if you don't know what red is, you cannot filter for red cars because you don't know this. So the thing is, by expanding your knowledge base, you are able to filter the world in ways that are more relevant to what you want to learn. Okay, you cannot learn things that you have no filters for. Essentially, like for example, if we are not able to sense X-rays, maybe you can't learn things about X-rays through our body. All right, you don't have that physical sense. But if you can connect an X-ray detector, connect it to some sensory vest, yes, then maybe you can learn the filter for X-rays. So essentially, yeah, individual filters are very important, but it's still a universal filter because you can filter it in any way you want. You just need to learn how to filter it, if that makes sense to you.
Okay, so universal in the sense the mechanism itself is universal.
The mechanism of filtering is universal, but the learned filters may not be because the learned filters are subject to your experience and memory of the world.
Okay.
Yeah, and of course your DNA and the body structure. I mean that's the sense organs filters. Yeah. Anyway, just a feedback. Is this like mind blowing to you, or is this something that you already like kind of knew before this? Just to get a sense.
Well, you mean like the non-materialistic aspect?
Yes, correct. And the filter by intent, that kind. Yeah.
I mean, I've been reading on like consciousness things like that along the way, but I think it's probably the first time I heard someone trying to connect the learning theory to the non-materialistic phenomenon. Yeah, that's
Yeah.
that's something new for me.
How about you, Derek? You wanted to say something?
Yeah, no, I'm the same. I've been fascinated by the non-material aspects, more of the high level aspects of the mind and the soul. I've always been fascinated by some of the harder to explain things. I'll put it like that. But this whole framework you've built around these concepts has been very fascinating. You actually have like an entire framework that I can immerse myself into. This is like a lot more in depth than I've seen anywhere else academically.
Yeah, I created this myself. So this is just basically based on my understanding of because I have a knowledge base for AI. And I read the non-consciousness text, and I just expand my knowledge base to fit those that I read, and it fits quite well. So this is still preliminary, as I said. As the more I read, the more I can map it better. And I would like to say that there's also a huge portion on action space modeling by intent, which I didn't cover it's not in the slides, but I will share in another session. Like how the intent drives actions and different levels of actions. I think this is not very well modeled in AI right now. We mainly model this part here. Yeah. So if we have automatic processes here as well, right now agentic frameworks are so slow. Like you do an action, do a chain of thought. Sorry, do an intent. Like you want to search Google, chain of thought, then search the query bar, search for google.com, right? Like these are very, very slow, conscious efforts. Like you can call it system one. No, system. Actually, system 1 and 2 is not a good word for conscious and unconscious. Like it's more of like slow, laborious, intentional effort to do stuff. But if you can model 2 levels of actions, your bodily response will be automatic, fast. Like let's say I want to search Google immediately without doing chain of thought, the query will go to search Google. Imagine that in an agentic framework where you have automatic responses for things that you already know that you need to do that. And yeah, you can have mind body in an agentic framework. You don't have to do chain of thought for everything. So there's a lot of good possibilities for all this. Quite excited to cover all this. Okay, I think that's enough. We have exceeded a bit. Yep, I'll see you all next week again. I'll continue the slides next week. All right. Yep. Thanks, everyone.